There were actually lots of physics formulas covered in week 3. First, the lecture clarifies how calculus has already evolved in our previous learning, specifically in Newton's second law, as shown here. The original formula to calculate the final velocity is to add each velocity change to the initial velocity, which if I convert it into calculus, we can get this expression. So the final velocity is equal to the initial velocity plus the definite integral of the vector f net divided by the mass m multiplied by the differential dt, integrated from the initial time to the final time. In fact, I didn't realize the existence of calculus when I saw computer run this expression code at the first time, and I never thought calculus would be involved in our learning this early. So I'm actually kind of surprised when I listened to this week's lecture. And the second concept is acceleration, which also exists in Newton's second law. So acceleration is defined by delta v divided by delta t, which is the left part of Newton's second law. Unfortunately, I noticed this when I first learned the Newton's second law. So when we replace the left part of the equation with acceleration, we can get this equation, which is pretty familiar to me, F net equals to ma. And the third idea discussed in the lecture is using the momentum principle to calculate the net force and use the computer model to test if the net force we calculated is correct. After listening to week 2 lectures on this topic, I found the codes shown in this lecture not that confusing, so I'm glad that I got more knowledgeable about coding and physics after listening to previous lectures. And the fourth and fifth concepts are gravity force and electric force, and the formulas are shown here. I'm quite familiar with these two forces, but we only focused on calculating the magnitude of the force in high school, whereas these expressions include not only the magnitude, but also the direction of the forces. I'm curious about the application of calculus to physics, because I've never applied calculus to any other science subjects before, and I'm actually not very good at calculus. So when I saw where is calculus, which is the title of the first lecture video this week, I was a bit nervous but also excited. After listening to the video, I found that calculus almost exists everywhere in science subjects, and I hope to learn more physics ideas where calculus is applied. Related to my own area of study, which is chemistry, I believe the use of interdisciplinary approach is also important in chemical concepts, although I don't know any examples yet, but I'll figure it out as I learn more. For me, the difficult topics covered in week 3 are calculus, as I mentioned above, and the electric force. Although I've learned electric force before, the concepts related to electricity and magnetism are just a little abstract for me, so it took me some time to fully understand the magnitude and the direction of the forces exerted on each object. After realizing I had some difficulty with these concepts, I checked the supplement resources provided in the module on Canvas, and I found the student wiki very useful to help me understand these physics ideas. For each concept, I found there were 3 examples of different levels, simple, middling, and difficult. And after looking through the 3 examples, my understanding of the physics concepts covered in this week becomes clearer and deeper.